Now tonight, we are very pleased to have Bob Sandford speaking about water. Bob is the Expert Chair for Water Security at the United Nations Institute for Water, Environment and Health. And in fact, he has co-authored, some of you are perhaps looking at it, this report, and he has generously offered it for free. So there's only a few if you'd like to grab your copy. Also, in our museum shop, we have quite a few of Bob's books. Please have a look after the presentation tonight. Without further ado, please join me in welcoming Bob.
Well, thank you very much for the kind of introduction. And I've got to say, I'm really pleased that so many of my friends would come out tonight. And I have to honestly admit, I was looking June night, long days, nice evening. Would I go? My presentation is in two parts tonight because it's so timely and such a pressing issue. I'd like to begin my presentation this evening, if I may, with a brief digression concerning the current drought conditions in California and their potential to impact this region of Canada. And I'd like to begin this digression with a brief observation on the importance of Banff National Park within the context of the Canadian Rocky Mountain Parks World Heritage Site. And what I find really interesting, it's very interesting to travel a great deal and still live here. And what I find is that while our failure to act on issues like climate change has had an effect on our reputation abroad, there's one thing that Canadians can retain great pride in terms of global Earth system protection. And what I want to say is that over the last century and a quarter, Canadians somehow managed to collectively recognize what they possessed in the Mountain West and to act upon that recognition. So instead of dividing the landscape into halves and quarters and eighths until it was utterly diminished and lost, as so often happened elsewhere in Canada, in the Rocky Mountains we somehow recognized the value of what we had. We stepped back from its destruction and slowly started putting it back together again. Now, we may not have always recognized clearly what we were doing or to what end our collective efforts were aiming. But the creation of the Canadian Rocky Mountain Parks World Heritage Site, in my estimation, is a public policy achievement of global significance. We made ourselves whole as a people by restoring the places that have in the past meant the most to our identity. And yet all of us, we don't fully realize what we have done. Though watershed protection was a fundamental ideal in the creation of our Western National Park and Protected Area System, this function has been eclipsed, probably for good reason, for many decades by a focus on landscape and wildlife protection, and more recently on tourism and also on visitor experience priorities. But suddenly what we find is that downstream population growth, increased agricultural and industrial water demand, and climate change have put the importance of these upland watershed areas back into very bold relief. And I think this presents an opportunity for a new and very vital focus that could be good for parks and also for people. What needs to be seen is that our changing hydroclimatic conditions present our national parks and protected places with huge opportunity to revitalize their organizations and further validate their core mandates around water and the service of the common good. And I'd like to remind you that these are the water towers of the entire West. And within the Canadian Rocky Mountain Parks World Heritage Site alone, there are a total of 44 rivers and 164 named tributaries. And only 2 of these are dammed. 4 of the greatest rivers on the continent are born here, and within its boundaries there are some 295 lakes and thousands of ponds and ephemeral pools and wetlands. And all of that water is the source of the region's biodiversity and the biodiversity of the downstream West. And I maintained for decades that the protection of this upland region is one of the greatest public policy achievements. And if we did it once, my view is that maybe we could do it again. And a second great public policy achievement in the West could be built on the first. And I believe that our upland, national, and provincial parks and protected places could become a crystal around which our entire nation could reaffirm the value of water to our identity as a people. So we've created this World Heritage Site. Now let us use it to demonstrate to the world how we can follow the water in our rivers and lakes back to the headwaters of our history. And from there we can identify the point in time where we made a wrong turn in terms of taking the importance of our water resources for granted. By following the rivers back to their sources, we might return to the headwaters of true sustainabilities. And I wish to say that, in my view, that there is great urgency in doing so. The global water crisis, not surprisingly, has manifested itself here also. And this crisis has been intensifying, particularly during the last 5 years. And I find it very interesting to be offering this presentation amidst Henry Bloch's work on glacial recession in the Rockies. In our work in the cryosphere, that area of the world covered by snow and ice, we have determined that we have lost some 300 glaciers in the region of the Rockies here in the 85 years between 1920 and 2005 alone. This loss is expected to continue with over 95% of the ice that exists in the interior ranges of Canada's western mountains expected to be gone by the end of the century. The Canadian West, clearly then, is on its way to becoming a very different place. And one of the things that I learned, the most valuable things I learned from Henry Bloch, however, was not about glaciers. It was about the value of studying and understanding the history of water policy and management in California. Because he always used to say, well, you should study that because it's coming to a theater near you. And that's clearly what's happening. The current drought in California is likely the most important hydroclimatic event of this young century. And I think there's a great deal we could be learning from it. The first thing we should understand is the world changed forever for everyone working on water and water-related climate issues. The moment scientific evidence proved that relative hydrologic stability has been lost globally. Now, we've been witnessing energization of the water cycle in Canada since our work with the UN here started, but we had no clear scientific evidence to provide support for our observations. Now, not all changed in 2011 with the publication of the U.S. National Academy's report that confirmed that unprecedented changes are being experienced in the rate and manner in which water moves through the global hydrologic cycle. We now realize that our current risk assessments with respect to climate disruption are built on confidence and relative hydrologic stability that no longer exists. And this, I should point out, changes everything. As a consequence of our influence in the composition of the atmosphere, we have interrupted the hydrologic cycle, resulting in the wholesale loss at high altitudes and latitudes of ice, permafrost melt, sea level rise, and certainly most troubling of all, changes to reliable precipitation patterns. And really, when you look at it, it's quite interesting. We had no idea until recently of how much influence the hydrologic cycle has on our day-to-day lives or on the broader conditions that define the distribution and diversity of life on this planet. What's really interesting is that it's been really difficult, even for experts, to grasp the full extent of what the loss of relative hydrologic stability means. To say that dramatic changes in the cyclic distribution of the 52 million cubic kilometers of water that are at any given moment moving through the hydrologic cycle will affect all of humanity is really an understatement. And what we've discovered is, if you look at this, it gives you a hint at it. What we've discovered is that 10 trillion tons of water are shifted from one hemisphere to the other in the form of winter snow cover during only one annual seasonal cycle. And the volume and weight of water moving continuously around the surface of the Earth and between the surface and the atmosphere annually is so great that it actually deforms the Earth's surface. And redistribution of the weight of water over the Earth's surface actually causes changes in the shape and spin rate of the planet, which affects the behavior of all the planet's fluid systems, including both the hydrosphere and the atmosphere. So water, we have discovered, is a tectonic and geophysical lubricant. The geology of the entire planet is responding to changes in the hydrologic cycle. And what we've seen is that in either its solid or liquid form, water has been shown to be capable of influencing potentially hazardous seismic activity, which elicits responses from the interior of our planet. We've observed, for example, that loss of glacier ice can produce a pressure drop on the Earth's crust equivalent to as much as 20 atmospheres. And the thinning of glaciers and the loss of major ice sheets can cause landscapes to rebound from under their weight, which can induce earthquakes, landscapes, and volcanic activity. Now, unfortunately, the problems associated with the loss of relative hydrologic stability are not going away. Quite the opposite. More and more evidence points to the fact that troubling changes in global hydrologic circumstances are actually accelerating. Now, we've now reached the level of 400 parts per million of carbon dioxide in the atmosphere, which is a threshold beyond which many climate scientists believe that step-like changes in the behavior of the climate system can actually happen very quickly. And some climatologists are arguing that we may have witnessed the beginning of a long-awaited jump in global temperatures, an almost instantaneous jump of 0.3 degrees Celsius. And we also know that step-like changes of this magnitude can occur over periods as brief as a few months. And many credible scientists fear that's exactly what's happening in California. California and the American Southwest appear to be facing what you'd consider perhaps to be a hydroclimatic double whammy, a cyclic return of drier conditions combined with the effects of warming brought about by changes we've caused in the composition of the atmosphere. And as a consequence of higher global temperatures, it appears the region has passed over an invisible threshold into a new weather regime in which drier La Nina conditions will prevail over time. And if that's so, the drought in California and the U.S. Southwest will be persistent, if not permanent. So from the California example, we also learned that the effects of rapid warming are never uniform. Deep and persistent droughts are followed by severe storms and flooding. It's kind of a 1-2 punch, and we're starting to see that here too. And it's this oscillation between extreme wet and dry conditions that knocks out our ecosystems. And that's as true on the Canadian prairies as it is in California. And what we know is now, looking at the longer geological record, that droughts of up to 400 years in duration have overlapped from the Southwest into California in the past. And the work of Dr. David Soshin at the University of Regina has shown that droughts of similar magnitudes have also occurred on the Canadian prairies. We've had century-long droughts. And what we've also seen in California is interesting, is a direct link between drought and mountain snowpack. And for each 1 degree Celsius rise in temperature snowline in the American West, for temperature, the snowline rises 500 feet, more than 500 meters. So at 3 degrees Celsius, the snowline will rise 500 meters. And what we see is that with a 3 degrees Celsius temperature increase, the Sierra Nevada will lose half of its winter snow. And what we've seen is that average snowpack in the American West has declined 10% in the past 100 years, and it's expected to decline 40 to 80% by the end of the century. So we can see that the types of water supply and water security issues that we see in California could be persistent. And there's also another element that I find very interesting, particularly concerning what has happened here in 2005 and 2013. There's a direct link between more precipitation falling as rain as opposed to snow in winter and the potential for flooding. So what this trend does is it increases the likelihood of warm rain on snow events in both spring and fall, resulting in greater flooding potential. I think that's something we need to pay attention to here. And of course, there is a direct link between drought and fire. When surface stream flow declines, groundwater depletion accelerates, and trees suffer, weakened by drought and insect pests, forests catch fire. And There are also, from this, important economic lessons we can learn from California and from a growing number of climate disruptions around the world. And what we see from this is that economic collapse in the region is often characterized by a loss of environmental carrying capacity for human expansion and progress, and it's an economic issue. And in Mexico, for example, the economic collapse there was brought about by a dual-linked influence of deterioration of soil health combined with a decline in water availability and quality that brought about the salinization of soils and a dramatic and almost instantaneous drop in agricultural productivity. And what we're seeing is the same dry conditions and associated environmental decline that affected Mexico are now impacting water availability and quality in California. Because it's wealthier and more economically diverse, California is likely to fare better, certainly, than Mexico, but there's no guarantees. And the lesson I think we should take away from the California situation and from earlier climate disruption is that we can, and likely will, adapt to these kinds of changes, but the price to do so might be very high. And we need to think about that here, now especially, because unfortunately, these same dry conditions that impacted California now threaten to present themselves in Western Canada. And while the circumstances here are not nearly as dire as they are presently in California, current hydroclimatic trends, they really demand our fullest attention at the moment. Dr. John Pomeroy holds a Canada Research Chair in Hydrology and Climate Change at the University of Saskatchewan, and he and fellow researchers monitor hydroclimatic conditions at a series of research sites throughout the Rocky Mountains. And careful monitoring has revealed that winter snowpack and snow cover on the valley floor in Kananaskis and in the Kananaskis region of the Rockies and in Canmore has declined by half since the 1960s. Snowfall was below normal during the course of this past winter. The little snow we had also began to melt a month earlier than normal. As a result, stream flows generated by spring melt also peaked a month earlier, and they did so from the American border north. By mid-May, the region was already in what we call hydrologic drought, which means that in the absence of snowpack and resulting stream flow to which we've become accustomed, precipitation could not keep up with evaporation, and this region began to dry out. But at that time, I have to say that we were still quite optimistic. But it was too early then to say that the drought would persist, because as you all know, as most of you are locals here, late June has historically presented us with reliable, and as we saw in the flooding of southern Alberta in June of 2013, sometimes quite substantial rainfall. And we had hoped that the June monsoon, as we call it, would relieve us of immediate drought fears, but that's not what happened. The much anticipated late spring monsoon fizzled, and maximum daily rainfalls were only in the order of 10 to 12 millimeters, and the wet mountain forests evaporated 6 to 7 millimeters of that rainfall each day. And as a result, there was almost no impact on already very low stream flows from the precipitation that we received. And you'll notice, if you live here and have lived here a long time, this isn't the usual June weather conditions. The flow of the Bow River is presently a quarter of what it is normally at this time of year. And as of June 15th, the snowpack in the interior ranges of British Columbia was at 5% of normal for this time of year. So this doesn't bode well for what stream flows will be like in late summer. And again, we must also remember that water is married to its diametric and symbolic opposite, fire. And as of June 22nd, there were more than 450 active wildfires in British Columbia. That compares to 270 at the same time last year. And you also have noticed perhaps that similar fire conditions exist in Alberta and in the Northwest Territories. And fire, as you probably know, doesn't just affect forests, it affects how much water forests can hold and release over time. So we're presently facing drought from Vancouver Island all the way to the Manitoba border. And we anticipate temperatures as high as 35 degrees Celsius this weekend. These summer temperatures are expected to persist for some time to come. Prairie soils are already dry. I think we're in trouble. Stay tuned. So with these remarks as a preface, I'd like to go back to a much abbreviated version of the presentation I agreed several months ago to offer tonight. And I'd like to begin that presentation, if I may, by explaining my work. Centered in Tokyo, the United Nations University System is comprised of 18 different research institutions located in 14 countries around the world. Each institution deals with a different challenge. So as it happens, the United Nations Institute for Water, Environment, and Health is located in Canada. It's at McMaster University in Hamilton. And the goal of my work with the UN is to build a better bridge between science and public understanding, and also public action on water and climate issues in Canada and abroad. And one of the principal roles of our initiative, which is hoped to see tonight, is to bring national and international example and good science to bear on Canadian water and water-related issues. And what our goal really is to put what others are learning elsewhere before the public and decision makers in Canada for their consideration. So I don't think I have to, if you came tonight, and I'm so pleased you did, and I'm so impressed that you did, I don't have to tell you, if you came tonight, that water and water-related climate matters have become truly hotly contested issues. And my principal focus is on water security. Water security means having and being able to reliably provide adequate water of the right quality where and when you need it for all purposes, including those related to sustainable, natural, biodiversity-based Earth system function. And it also means ensuring that your use and management of water in the region in which you live does not in any way negatively affect the water security of regions up or downstream from you now or in the future. What's interesting is that definition has changed over the last decade. Water security has come to mean being able to achieve these goals in the face of new circumstances created by the acceleration of the global hydrologic cycle. And the intensification of this cycle is brought about by, as I said, these changes in the composition of the atmosphere. So this means that water security means managing not just the water you once thought was reliably available to you, but also managing water in sometimes far greater extremes of abundance and scarcity than you may have experienced in the past. And what we realize now is that water security and climate security are absolutely inseparable. In fact, one is implicit in the other. In fact, it could be said that water security and climate security are the same thing. So if you came tonight, you probably realize that these water-related climate issues are critical matters. But what's fascinating, traveling and then coming back to North America, is that these concerns are not something people like to talk about. And one of the really big challenges we face right now is that outside gatherings like this, there's a silence even around the silence related to climate change. And because of the growing economic consequences of ignoring this threat, this silence is beginning to attract a surprising amount of attention. And some of it's quite amusing, actually. At a very high-level meeting on the communication of climate science, sponsored by the World Bank in Washington last November, this very distinguished senior U.S. scientist shocked his equally staid colleagues with just an absolutely scandalous remark. So I wish you be prepared to be scandalized by this. He said, climate change is the new sex. Everybody knows about it, a lot of people get it, but nobody wants to talk about it. So if you feel uncomfortable, you can imagine how these people feel. So, why the silence? Philosophers and sociologists have been examining the silence for some time, and they found that some people don't want to talk about climate disruption because they simply don't believe it's happening. The fundamental laws of atmospheric physics and our already demonstrated impacts on the global ocean notwithstanding, they simply don't accept that people could have that kind of impact on the entire planet. Many older people, they found, do not want to talk about climate disruption because they think it will not affect them in their lifetime. It's too late for that now, however. Reincarnation, notwithstanding, climate disruption has already begun. Still others don't want to accept climate disruption because they don't like or trust the people who are sounding the alarm. They simply don't share the same views or values, and they don't trust environmentalists. Many who are of this view reason that if climate disruption really was the threat that environmentalists claim, then mainstream political and market energies would already be focused on addressing it. Some people deny climate change because they ideologically oppose the extent of the presence and influence that government would have to address a problem that can clearly only be resolved through common cooperative action and sacrifice. It's also been found that a great many others don't want to talk about climate disruption because they are consciously and unconsciously troubled by the moral, ethical, and legal implications of not having acted upon what they know. And the central factor that determines moral and hence legal responsibility is intention to harm. And certainly no one intended for climate change to happen, and no one, as far as we know at least, has set out to intentionally harm anyone else by contributing to climate change. Or at least that was the case at the beginning of the climate debate. But now, with 5 Intergovernmental Panel on Climate Change assessment reviews before us, and clear evidence of climate disruption on the television news every night, it's getting very hard for interests to claim innocence when it has become clear they are, in fact, contributing significantly to the problem. So the question, from a moral and ethical point of view, these researchers tell us, is this. Once evidence clearly demonstrates that you are harming others by contributing to climate disruption and don't do anything about it, at what point does the harm you are causing become intentional? At what point does the fact that you refuse to acknowledge what you're doing is causing harm to others and to future generations become morally and ethically indefensible? At what point does willful blindness become negligence, and at what point does negligence become crime? Now, I'm sure there's not a person in this room that wouldn't agree that this has the potential to turn into a royal mess, to say the very least. Many politicians would rather remain silent on the climate question rather than risk opening the door to the pending societal divisiveness that could crowd into the room behind moral, ethical, and legal liability claims of this kind. And in the middle of this is the average person, us, who would really just like to have the opportunity to carry on with the business of being. They often remain silent, so it just will go away. And the problem is that it's not likely to do that. It's become very clear to those of us working in this domain that the climate issue has the potential to tear our society apart. And it's the duty, I think, of everyone in this room to prevent that from happening. Our strategy so far has been to try and fix this problem internally without conflict, but unfortunately we've run out of time. We're not going to be able to keep the undeclared civil war that we're trying to contain secret much longer, and the problem is water. So as many of you know, even the best hydroclimatic models can only reveal a glimpse of how implicit water is in the construct and maintenance of our earthly reality at any given time. Our reality is literally saturated with water, and life made possible by all the ways in which water reacts with nearly every element in the physical world. And what we discovered is if you change a few parameters that pertain to water, and the world you see out the window becomes very different. Some parameters, though, have more influence than others over the nature and function of any given hydroclimatic circumstance. The changing of a single defining parameter, like temperature, for example, changes all of the other biogeochemical parameters. And as temperatures change, what happens is an entire new geometry is created around that change. And the most frightening discovery, perhaps, of this young century is that that is exactly what's happening. And it's happening right before our eyes, here and everywhere. In a sense, the genie's out of the bottle. So, upon what evidence could one make this claim? Well, this is the 360th consecutive month during which temperatures were above the 20th century average globally. So if you're younger than 29 years old, which is to say you're born after the end of March 1985, you live in a different climatic regime than those who came before you. And nor will the climate in which we currently live be with us for long. Projections by the normally staid and highly conservative World Bank put average global atmospheric temperature increases between 4 and 6 degrees by 2060. Now, if the World Bank projections are correct, we are very definitely going to be living in different circumstances soon. And thus we arrive at the realization that perhaps the most important question we should be asking at this critical point in our human journey is this. What will happen to water and the water cycle if the mean average temperature of our planet's oceans and land surface continue to rise? Well, we know that. The first thing warming of the atmosphere does to the global water cycle is increase the amount of water vapor that the atmosphere can hold. And again, this is very basic atmospheric physics. For more than a century, we've known exactly what changes in the amount of water vapor will occur in the atmosphere in response to any given change in temperature. We know for certain that for every degree Celsius of warming, you can expect the atmosphere to carry 7% more water vapor. So if you increase the temperature of the atmosphere by 2 degrees, the atmosphere can carry as much as 14% more water. And if you raise the temperature 4 degrees, it'll carry 28% more water vapor. And that changes everything. And that is exactly why recently identified phenomena such as atmospheric rivers demand our fullest attention. These huge rivers of water vapor aloft are carrying more water and causing flooding of magnitudes that we haven't witnessed before. And we recently discovered that atmospheric rivers derive their energy from temperature differences between the tropics and the poles. And their intensity also derives from the relation that I just showed you, in that the warmer the air, the more water atmospheric rivers can carry. Now, I want you to take a look at the left-hand top map. That's an atmospheric river stretching across the Pacific and hitting California. And it's really interesting to note that in addition to droughts, California's droughts are prone to very, very big floods. And California's biggest floods have been caused by storms that are popularly known as the Pineapple Express. Undoubtedly, some of you have experienced that. These storms are atmospheric rivers that collect huge amounts of water vapor as they cross the Pacific from Hawaii and unload it as heavy rain when the storms hit the coast of North America. And when moderate in scale, they bring badly needed water to dry states like California. When larger in scale, they cause flooding of a magnitude that we can hardly imagine. The atmospheric river that caused epic flooding in California during the winter of 1861 to 1862, for example, hammered the west coast of North America from Mexico to Canada for 43 days. The U.S. Geological Survey has published a new emergency preparedness scenario which demonstrates that if struck by an atmospheric river event, like the one that happened in California that year, the state would lose 1/4 of its homes with a projected damage of $725 billion. Can you imagine that damage on top of the flood damage? And the other thing we need to keep in mind is that water vapor is a powerful greenhouse gas in its own right. So the more water vapor there is in an energized atmosphere, the warmer it becomes. So you can see how that becomes a climate feedback in its own right. And what's also interesting, from a Canadian perspective in particular, is other critical weather phenomena are also tremendously affected by differences in the temperature gradient between the poles and the tropics. And what we're seeing in Canada is that the loss of Arctic sea ice and the rapid reduction of the extent and duration of snow cover in the northern hemisphere are reducing this temperature gradient between the poles and the tropics. And it's this difference in temperature between the polar region and the warmer air to the south that largely defines the behavior of the jet stream. And the less ice there is in the Arctic, the slower and wavier that jet stream wind becomes, then the more erratically it behaves. And we see from the altered behavior of the jet stream that warmer atmospheric temperatures do not automatically translate into warmer weather. In a uniformly warmer and therefore more turbulent atmosphere, both warm and cold fronts end up and persist in places in mid-latitudes where they weren't common in the past. And we've seen that, less in the west, but more in the east. That's why, in combination with the atmosphere's capacity to hold more water vapor, both summer rains and winter snowstorms are persisting longer and causing greater and greater damage. And so I want to point out, for those of you gamblers, you can see from this that the Arctic is not like Las Vegas. What happens in the Arctic doesn't stay in the Arctic. So we see from this that changes in atmospheric circulation are pushing major subtropical storm tracks toward the poles, often causing flooding of magnitudes we poorly equipped to manage. This has been really interesting to observe because we've seen over the last 10 years, we started with a history of our biggest flooding coming from spring snowmelt. And then we found it from, not from spring snowmelt so much as from big storms that occur independent and beyond and after the snowmelt occurs. So that storm intensity is increasing was obvious all across Canada during the summer of 2014. But most devastating clear on the Canadian prairies, which experienced catastrophic flooding for the second time in 4 years. So in the past decade, and what we see is the most obvious effect of hydroclimatic change on the central prairies has been this poleward advance of subtropical storm trends. But as we predicted all along, there's another problem, and I pointed to this in my introductory digression. The specter of deep and persistent dump. We know that there are invisible thresholds that will be crossed as mean temperatures continue to rise. And here's the thing we know now. Temperatures on the prairies are expected to rise between 5 and 8 degrees Celsius. What we don't know is what threshold the temperature increase will cause the hydrologic decline to drop on its dry side. All we know is that sooner or later it will, and it may happen. Now, I want to point out something very interesting in this context. At the same meeting, the World Bank, to which I referred earlier, it was pointed out that there was real urgency in doing a better job of helping others understand how our hydroclimatic circumstances are changing. Now, we of course know that hydrologic conditions on this planet have always been changing. And we also know that we've been fortunate enough to have a century or so of relative hydroclimatic stability. We now know, even the World Bank declares this, that era is over. The long-term hydroclimatic stability of the climate we experienced in the past is not going to return during the lifetime of anyone alive today. But what we haven't understood until now is the extent to which the fundamental stability of our political structures and global economy are in part predicated on relative hydrologic predictability. And as a result of the loss of relative hydrologic stability, political stability and the stability of our global economy in a number of regions in the world are now at risk. We're only now beginning to understand how absolutely complex this is, how implicit water is in everything that we do. This is a map of interconnections between various environmental, economic, geopolitical, societal, and technological risks associated with the failure to effectively and meaningfully adapt to climate impacts. It was presented by the global insurance giant Munich Re earlier this year at the World Economic Forum in Davos. And what this map illustrates is the cascading effect of the failure to understand fully what's happening. On a global scale, failure to address these issues leads first to greater vulnerability to extreme weather events, food crises, water crises, large-scale involuntary migration, further man-made environmental catastrophes, which turn into biodiversity loss and threaten Earth system collapse. Now, I want to point out this is the World Economic Forum talking here. These risks are not theoretical, they're real. And a strong case was made recently by the World Bank that hydroclimatic destabilization is a major threat to advancing development, hence the report that we published. And extreme weather events are now, in fact, seen to be reversing development in many regions. An example of this is Pakistan. In 2010 and 2011, Pakistan was affected by major droughts caused by heavy rainfall during the monsoon period. Land use changes that altered natural drainage patterns and river flows, aggravating the flood risk. And if you haven't heard about this, this may shock you. More than 2,500 people died. 27 million people, almost the entire population of Canada, were displaced. The economic losses, direct economic losses, were estimated to be $7.4 billion US. But what's interesting is the country's development was reversed, set back possibly decades. And in a separate meeting with the Disaster Risk and Climate Change Unit of the World Bank, and note I'm talking about a bank here, not an environmental lobby, it was clearly stated that we now have to start thinking the unthinkable. And the unthinkable, of course, is that these kinds of events might reverse development here in North America, thereby reducing or threatening our prosperity. And the fact is, this is already happening. In 2014, the Weather Channel published a list of 50 U.S. counties which they identified as being of high risk in terms of weather, climate, and natural disasters that damage and destroy homes, putting lives and livelihoods at stake. Now, the question you got to ask about that, who would want to live in places like this? How could such places sustain their tax base? How can such places stem the trend toward reverse development? And what we're seeing is that climate-related de-development is already happening in Canada also. We just don't see it that way. And where it's happening is in southern Manitoba and also in Atlantic Canada. And so I'll be pleased to put forward evidence to this point. After the flood of 2011, our initiative worked closely with University of Saskatchewan and Sandford Hydrology to analyze the hydrologic circumstances as they were changing on the prairies. And as I said, we were of the view that we crossed into a new hydroclimatic regime in which there was an increasing likelihood of a significant increase in flooding. And what's really interesting from this is that we stated that we feared that the crossing of this threshold could over time bankrupt provinces like Manitoba. And you can imagine they paid attention to that, and you can also understand that we didn't say that flippantly. That year, a quarter of Manitoba's productive farmland went unseeded. The total cost of flood damage in 2011, combined with disaster relief in Manitoba alone, was $1 billion, which was almost exactly the amount of the province deficit the following year. And that damage didn't stop there. Lawsuits totaling another $1 billion were later brought forward as a result of that flood. You may notice there's still people living in Winnipeg that lost their homes and have not returned to them since that flood. And again, as I said, the same level of flooding occurred again this past summer. Now, here, most of us here consider that 2013 was really the year that the prairies crossed this invisible threshold into a hydroclimatic regime. But I want to point out to you, despite all the attention it received, it was not the spring flooding in Alberta that provided evidence of that transition. It was flooding in Colorado later and also on the prairies later. Now, the flooding in Calgary, interestingly enough, was a 1 in 45-year event, well within the natural variability we've come to expect over the last century. Now, Calgary and area just weren't ready for it. But let's look, in the same vein as Manitoba, at the economic and political fallout. The damage associated with flooding in southern Alberta was estimated, not including some of the indirect costs, at $6.5 billion, making it the largest natural disaster in the history of Canada. What happened is a year later, the oil prices dropped. And Alberta's deficit was projected to be at least $5 billion. But I think what's more interesting than that is the public perception of the entire issue. The flood, in effect, revealed that the financial reserves in the richest province in Canada were only adequate to keep government programs operating for a few months. And the 2013 flood put into relief what many Albertans considered to be fiscal and political mismanagement of the province. And some of you may remember this election in Alberta recently, which I thought I was away, but I had voted. But I heard one commentator say that they observed that hell suddenly froze over. So what we see from that is that extreme weather is going to be a critical issue in Canada. And I think that careful examination of how our hydrology is changing suggests that we might have to reframe our situation so that we can think about it differently, so we can adapt more quickly and effectively. And one way our current situation is being reframed globally is through the notion that we have entered a new geological era in which human activities rival the processes of nature itself. So what is this new geological epoch, and how is it different from the geological periods of the past? This new geological era is being called the Anthropocene. And unlike earlier epochs in the Earth's history, which were brought about by meteorite strikes and other geological events which resulted in mass extinction, this epoch is marked by our overall impact on the Earth system. And climate disruption is only one of these impacts. By virtue of our numbers and our activities, we've altered the global carbon, nitrogen, and phosphorus cycles. We've caused changes in the chemistry, salinity, and temperature of our oceans and the composition of our atmosphere. Changes in the composition of the atmosphere in tandem with land uses and our growing water demands have also altered the global water cycle. And the cumulative measure, the extent to which we cross these boundaries, is the rate of biodiversity loss. So what this means is that we have entered an era in which we can no longer count on self-willed natural landscapes to absorb human impacts on Earth's system function. We have to assume responsibility for Earth's system function ourselves. And with respect to humanity assuming responsibility for directing previously self-regulated functions of the Earth system, I have to tell you that I'm haunted by General Colin Powell's advice to President Bush on the risks of going to war in Iraq. He said, if you break it, you own it. And if we disrupt the stability of our biodiversity-based planetary life support function, then we're going to have to recreate those functions ourselves. We might be able to do that briefly for a space station, but we don't know how to perform these functions for the planet that created the conditions suitable for life that we emulate in space. We don't know how, and nor could we ever afford to turn the Earth into a space station. So if you break it, you really do own it. So it's widely held that whether or not we want to remain in this new geological epoch, the Anthropocene, is something we should be talking about. We should be talking about that in our communities, and we should be talking about that globally. At the very least, the satisfactory, at least tolerable coevolution of the ecosphere and the anthroposphere should no longer be an option. So the question you might ask as we move to conclusion is, well, what do we do now? Well, there was a time, and perhaps some of you have experienced this yourselves living here, there was a time when I thought that the first clear signal that the public would pick up with respect to the extent and rate of our climate change would be the obvious decline in local ecosystem function. But you know what, I have to admit that I was wrong. The surprising thing about ecosystem is how resilient they are. Under the influence of changing temperatures, they'll move out from under you, leaving in their wake opportunities for invasive species, which will succeed or fail as they might until some sort of ecosystem stability emerges. And, you know, as long as human numbers and activities don't cause the Earth system to move to a completely new and different state, life on Earth is likely to adapt as it has for billions of years to these changing conditions. Now, we may find ourselves in what we considered much altered and a much diminished world, but life's going to carry on. But what I have found, and perhaps you've seen this too, is what has captured public attention with respect to climate disruption is the increasing threat it is posing to public safety and its growing impact on expensive public infrastructure. The cost of climate disruption is enormous, and it's been rising for 40 years. So it's becoming clear that our failure to break the silence over climate disruption and change our behavior as a society could cost us our prosperity. It could also cost some of us our lives. What the loss of hydrologic stability tells us that true sustainability may be beyond our grasp if we don't do the right thing now. And that means that we may have to review and examine sustainability in a completely new light. Sustainable development, as we've defined it in the past, is not enough. What we need is restorative development. We cannot simply accommodate ourselves. We have to put vital Earth system function back in place in doing so. So how Canadians do with this? Well, according to the 8th annual RBC Canadian Water Attitudes Survey, Canadians' attitudes are actually starting to shift. But that shift is very slow. 4 out of 10 Canadians still have no idea where their drinking water comes from, and this has changed very little since the survey began 8 years ago. The survey also shows that we're still complacent about climate change. Very few Canadians have realized that our hydrology is changing. Only 28% of Canadians are concerned in any way about the future of water security we might face. So where is the shift I'm talking about? Here it is. In 2015, the survey found that 7% of Canadians were personally affected by flooding in 2014, and 27% knew someone personally affected during that time. And the point I want to make here is it's really just a matter of time before a growing number of people personally affected by climate disruption forms a constituency of its own. And you can bet that if what we've seen elsewhere in the world is any indication that the economic consequences of climate disruption won't be the only concern on the political agenda of this constituency. The moral, ethical, and legal implications but climate disruption will be high on the political agenda of this constituency also. So to restore our global hydroclimatic circumstances to tolerable stability, we have to break the socially constructed silence related to climate disruption. And perhaps the best way to do that is to start a conversation about something we all agree none of us can do without, and that is water. So how might the average person enter that conversation? Well, I think we should give consideration to how we're going to protect our families, personally, how we're going to protect our families, our property, and our livelihoods from hydroclimatic change. We can't wait for the UN or our governments to do that for us. It would be helpful if each of us knew where our water comes from, how much of it we use, and what we use it for. It would be helpful if we all understood that no matter where we live, we cannot count on having the amount and quality of water available to us now available in the same ways to us in the future. It would also be helpful if we publicly recognize that the water we take for granted now is going to be more valuable in the future than we can even begin to imagine today. It would be helpful also if all of us acted accordingly with this knowledge. One of the most immediate and cost-effective ways to make where we live the kind of place that people want to live and not leave in a warmer world is to invest in thoughtful, forward-thinking management of our total water and related resources. And I think our First National Park is a good place in which to contemplate the fact that catching up with and staying ahead of hydroclimatic change demands that we decide what kind of hydroclimatic steady state we want where we live, and then set self-regulation on the road to achieving that state. Clearly, we understand now that continuing to address hydroclimatic change in the way that we are now will eventually bankrupt us. At present, water and climate security are still within our means. Achieving this goal, however, will require relentlessly courageous citizenship and inspired political leadership based on new ways of thinking and more effective ways of communicating. What I think is needed most now, however, is a sense of urgency. We know what to do, but we have to do it. Welcome to the Anthropocene. Thank you very much.